friction forces. So in this presentation, I'm going to be talking about my big question in global warming, physics concept of friction, scientists involved with friction, and carriers involving friction. My big question will be answered, and solution to global warming, and closure, a little summary, and the references I've used. So, my big question is, how can the reduction of friction in transportation systems help in mitigating the impact of global warming? So, let's talk about what global warming is. Since the Industrial Revolution, global temperature have increased by over 1 degree of Celsius, with the rate doubling since 1981 due to the increase of greenhouse gases. Gases like CO2, hydrocarbons, NO2, NOSO2 absorbs the heat from sunlight and emits it back to Earth. This is called the greenhouse effect. So, what creates these type of gases? Human activity, such as combustion of fossil fuels, raises the amount of greenhouse gases in the Earth's atmosphere. Now, what is friction? Friction is the force preventing relative motion between two solid surfaces, fluid layers, and material components. So, how does it occur? When two surfaces interact with each other, the microscopic irregularities of these surfaces stand in the way and holds the two surfaces together and prevents it from shifting. Now, there are two different types of friction in solid materials: static friction and kinetic friction. Static friction occurs when two surfaces are in contact and stationary. A force needs to be applied to accelerate the two surfaces away from each other, and the force opposing the applied force is static friction. Kinetic friction. When two surfaces are in contact and moving relative to each other, there will be a force opposite to the direction of movement. That force is kinetic friction. Now, let's solve a problem involving kinetic friction. So, there's a guy on a sled, and their weight is 60 kilograms, and the coefficient of friction is 0.1 between the snow and the sled. They're moving at constant velocity. How do you find the force of friction between the snow and the sled? So, first, we use the formula friction equals mu times force normal. Mu is the coefficient of friction. Coefficient of friction is basically how much friction is between two surfaces. Now, force normal can be broken down into mass times g. And mass is 60 kilograms. G is acceleration due to gravity, and that equals to 9.81 meters per second squared. Now, 60 times 9.81 gives you 588.6 newtons. Now, that times the coefficient of friction, which is 0.1, gives you 58.9 newtons rounded. And that is our force friction. Let's solve a problem involving static friction. So our mass equals 2 kilograms and coefficient of friction is 0.5, and we have to find the force friction static. So now imagine someone's trying to push this book along the table. Before it starts moving, there's a certain amount of friction that you have to overcome, the static friction. And now we figure out how much is that. Just like kinetic friction, the formula for static friction is friction static equals force friction static equals mu times force normal. Now, as I said before, force normal can be broken down into mass times acceleration due to gravity, and that times 0.5, and that gives us 9.81 newtons. let's talk about a scientist that did great work to improve our knowledge about friction. Gallium Amontons. Amontons, a French physicist and inventor, made contributions to the field of thermodynamics and friction in the late 17th century. He formulated the laws of friction known as Amonton's law, which describes the relationship between frictional forces and the applied pressure and surface area. Amonton's work helped understand heat and friction, which had a great influence on scientific and engineering practices during his time, and paving the way for advancement in these fields that continue to shape our world today. Amontons was born in Paris in 1663 to be exact. Despite his personal challenges, including losing both his hearing and speech at a young age, he became a noteworthy figure in the science world, and he passed away in 1705. Now, let's talk about Amonton's laws. His first law: the frictional force between two surfaces is directly proportional to the applied pressure or normal force pressing the surfaces together. As the normal force increases, so does the frictional force. Second law: the frictional forces is independent of the apparent contact area between two surfaces. Even if the contact area changes, the frictional force remains the same as long as the applied pressure or normal force remains constant. Carriers involving friction. Tribologist. You might never even have heard of a tribologist, but it is a really cool carrier in my opinion. A tribologist is an expert who specializes in science and engineering of interacting surfaces in relative motion. They study and apply principles of friction, lubrication, and wear to analyze and find solutions for surface-related issues in various industries. To be a good tribologist, you need a minimum of 4 years degree in engineering or physical sciences, which includes foundational coursework in mathematics, applied mechanics, material science, physics, and chemistry. Physical chemistry and thermodynamics are also covered in these lectures. To be a good tribologist, you need skills such as critical thinking, problem solving, and research skills. In America, a tribologist makes an average of $161,000 and 140 lowest and a highest of $188,000 a year. So now let's answer my big question. So my big question was, can the reduction of friction in transportation systems help in mitigating the impacts of global warming? Yes, it absolutely can. So, 29% of the Earth's greenhouse gases are from vehicles. 28% of the energy burnt in an internal combustion engine is used to overcome friction within the vehicle. Reduction of friction in moving parts of a vehicle will help increase efficiency and overall performance. So, higher efficiency means less fuel burnt and less emission of greenhouse gases, which directly affects global warming. Also, less friction reduces wear and increases durability of the machine's internal parts, which increases its life expectancy. This means less emission in the manufacturing process of these parts, because less parts need to be produced. So, to answer the question further, 50% of the fossil fuel burnt worldwide is used for transportation. In 2016, 5,635,423,181,310 liters of fuel was burnt. That is a lot. And around 2,800,000,000,000 of it was used for transportation, which again is a crazy amount. And 790 billion liters was used to overcome friction. And let's do some calculations here. Every liter of fossil fuel burnt produces roughly 1.5 kilograms of CO2. This means 1,975,000,000,000 kilograms of CO2 was produced due to friction and overcoming it. Achieving a frictionless surface is impossible, but if at least 1% of the friction in a vehicle was eliminated, just 1%, then the production of 70 billion kilograms of CO2 could have been prevented. And this is just in 1 year. That is so much carbon dioxide. Now, that is a lot of damage to our planet. So, what are the solutions? What can we do to make the situation better? The number one thing we can do is switching to electric cars. Right off the bat, electric cars don't create CO2 as they don't have the internal combustion engines that most vehicles today have. And they have fewer moving parts, which means less friction and more efficiency. And another thing that will really help in eliminating the friction in vehicles is using lightweight materials to build vehicles. The lighter a vehicle is, the less pressure is put on the moving parts of the vehicle. As we discussed earlier, according to Edmonton's law, less pressure results in less friction, decreasing rolling resistance. For example, in the early days, engine blocks were made of iron, and now it's made of an alloy composed of mainly aluminum. The reason for this is the newer material is less heavy, and it might not be a lot, but over time and as many people begin to use the lightweight material, the benefits build up. And number 3, regular oil changes. Over time, debris from wear gets collected in oil, creating sludge and increasing metal-to-metal contact, raising friction. So, to conclude this presentation, friction plays a huge role in our day-to-day life, and it holds the world together. Literally. I mean, imagine if there were no friction anywhere. Everything would just start sliding away. The cup on your table, the computer, the phone, everything would just start flowing away. But as we discussed earlier, there are disadvantages to friction also, and eliminating it in the right places will make the earth a better place. The relationship between global warming and friction in transportation emphasizes how crucial the role of friction plays in production of greenhouse gases, and suggests that lowering friction might directly slow down global warming. My research shows that the sizable quantity of CO2 created as a result of friction and the potential effects of even a little bit of reduction in friction is huge. Thank you so much for listening to my presentation. I hope you enjoyed it and learned something.